All right, the very last thing we have to look at in this chapter, and before Christmas, woohoo, you're getting so close, is how the mole relates to chemical equations. What is really cool is the coefficients in a balanced, please note balanced here. If it's not balanced, this is not a true statement. The coefficients in a balanced equation represent the number of moles. Okay, so let's look at this example. This is a decomposition of hydrogen peroxide, but it doesn't really matter what it is. This is our example. This 2 means that 2 moles of hydrogen peroxide decompose into 2 moles of water and 1 mole of oxygen. All right, so what is really cool about this is now we can almost treat this like a recipe or a ratio because we know the number of moles needed. This is why it was so important for you to learn how to balance equations correctly in Module 6 and how to learn to write them correctly at the beginning of Module 7, because now we're going to put math on top of that. So what's really neat is because these numbers, and remember this is like an understood one here, I'll write it just to help us visualize, represent moles, we can get mole ratios. So for 2 moles of H2O2, I make 2 moles of H2O. For every 2 moles of H2O, I have 1 mole of O2. Okay, and I think there's one more here. For every 2 moles of H2O2, which is hydrogen peroxide, I have 1 mole of O2. Okay, and you'll see me leaving the E off the mole. That's just a way to abbreviate it in chemistry and in problems, and just the same way we put G instead of grams. Okay, so these are our mole ratios that can come from this balanced equation. Okay, and realize mole ratios exist for any balanced equation out there. Okay, so these are true for this equation, and for another chemical equation, they would be something different. But what's really cool is now we can use those as a recipe, all right, to change between my ingredients. So if it takes 2 moles of H2O2 to make 2 moles of H2O, what would happen if I had 4 moles over here? Well, I hope you see, if I had, this was a 4, then this would be a 4, and that would be a 2. The ratio would hold true, all right? These mole ratios would hold true, but they could reflect different numbers and different amounts. Okay, so let's take a look at a question involving this reaction. If 1.5 moles of H2O2 decompose, how many moles of O2 are produced? Okay, so let's start with what we have. I have 1.5 moles of H2O2. Okay, and then write down what you want to get to. I want to get to how many moles of O2. So I want to change to moles of O2. I have this suggestion for you. If you are struggling with these types of problems, learn to do this type of setup. Okay, on the left, write down what you have. What number and what unit are you beginning with in the problem? So in this case, I'm beginning with 1.5, and my unit is moles of H2O2. Okay, and then write down on the right-hand side, what do you want to get at the end of your problem? What is the question asking? So read the question. How many moles of O2? So I want to change to moles of O2. If you're struggling with these, you've got to be able to read them and say, okay, this is what I have, and this is what I'm changing to. All right, and then we're going to set up our conversion unit. So I want to cancel moles of H2O2, and I want to change to moles of O2. Okay, well now this looks different. In the last video, I talked about grams and moles, and they were of the same thing. This one is of 2 different things, moles of O2 and moles of H2O2, and what is cool is the periodic table, the balanced equation relates them together. So go look. I have a 2 in front of the H2O2, that represents moles of H2O2, and I have a 1 in front of the O2. Okay, so essentially, I use a balanced equation to get my mole to mole ratio. Okay, that is what makes balanced equations so powerful, is they can relate amounts of different things to each other. The periodic table can't do that. Okay, if you recall last time, I changed moles of water to grams of water. It was the same thing. Okay, the balanced equation allows us to change moles of hydrogen peroxide to something completely different, moles of O2, using the ratio. So here it's going to be 1.5 times 1 divided by 2. Okay, so I'm basically going to get 0.75 moles of O2. Hopefully you found that really easy. Let me show you how Apologia is going to make it hard. During the decomposition of C2H6O, if you start with 2.5 moles of C2H6O, how many moles of carbon are produced? Okay, you will notice something very key is missing here. A balanced equation. I cannot solve this problem without this equation. That's true for this problem too. Without an equation, it cannot be solved. Apologia wants you to write the equation, balance it, and then do the math. Okay, that's why they taught you how to write decomposition, formation, and combustion reactions equations at the beginning of this module. Okay, so let's look at this one. We're dealing with decomposition. So that means I write C2H6O on this side, and on the other side, I write all the separate elements that it came from, or that's decomposing into. So I'm going to write C, I'm going to write H2 because it's diatomic, I'm going to write O2 because it's diatomic. Please don't forget your diatomic. Now I'm going to balance it. Okay? I can't solve the math problem until I have written and balanced the equation. Okay, so you've got to realize that. You've got to realize when you read this problem, the key thing that's missing is a balanced equation. If I'm going to use my moles and I'm going to get a mole ratio, I've got to have a balanced equation. Okay? So probably what I would do is start with the C here. Okay, there's two C's, only one C, so I put a 2. Then I'd move to the H's. There's 6 H's here, only 2 here, so I'm going to put a 3. Oh, then my O's. Okay, there's 2 O's and 1 O, so I'm going to have to put a 2 here, which means now this is 4 C's. That's a 4. And now this is 2 times 6 is 12. So I need to make that a 6. Now I'm balanced. Now I can move on to the math problem. See how they're going to do that to you? There's already example problems that way. I'm sure there's some on the test. You've got to be able to write and balance the equation and then come on top and do the math. Okay, so I'm starting with, again, what do I have? I have 2.5 moles of C2H6O. What do I want to get to? How many moles of carbon? So I want to change to moles of carbon. Okay, so moles of C2H6O on bottom, moles of carbon on top, because again I want to cancel this unit and change to that unit, just like a conversion factor, only this time we're not using the periodic table. Okay, so here's another question you might be wondering is, how do I know when to use the periodic table and when to use a balanced equation? Well, the periodic table is to determine mass and grams. Nowhere in this question did it ask for mass and grams right now. So we're using the balanced chemical equation because it's asking for moles of one thing to moles of another, which means we need the mole to mole ratio. So I go to my balanced equation and I look for what number's in front of C2H6O. Well, that's a 2. And what number is in front of C? Well, that's a 4. Okay, so my math is going to be 2.5 times 4 divided by 2, and I'm going to get 5 moles of C. Now over here, this was 2 sig figs. These are counting numbers, okay? The 2 and the 4 and the 6 and the 1 here, the understood 1, those are counting numbers, so they don't count. So probably I need 2 sig figs here, so 5.0 would be the better answer, moles of carbon. Okay, hopefully those were pretty easy for you. Next chapter, we're going to relate the two together. The atomic mass that we learned last video on the periodic table and the mole and chemical equations. But for now, I'm pretty sure Apologia keeps them pretty separate. So just make sure you understand when to use the periodic table to do the mass and when you need to write and balance the chemical equation and use the mole to mole ratio to change from moles of one thing to moles of another. Please let me know if I can help you in any way. If you have any questions about what's been covered, especially in Module 7. It's a very important module. You really need to understand it well to set you up to succeed next semester. So please, you've got my email. A lot of your parents have my phone number. Call me, send me an email. Let me know if I can help explain this in any way. And I hope y'all all have had a good end of your semester. I hope you have a wonderful Christmas break, and I will see you in January for Module 8. Be looking for an email in the next couple of weeks, if you haven't already gotten it by the time you watch this video, that will have your schedule for the second semester on it, that you will be starting that first, I think it's technically the second week in January. Whenever co-op starts, you'll need to start that schedule. So you'll be getting that soon. Hope you have a wonderful Christmas and a Happy New Year. Bye.